In our previous video, we have seen various properties of images formed by concave mirrors. This table represents those properties. Depending on where the object is kept away from the mirror, the properties of the image vary. If you remember, this wasn't the case for plane mirrors. The image properties were the same irrespective of the distance of the object from the mirror. Here it's not the case as we had seen in the last video. Only one property of the images is remaining which we haven't determined yet. And that is the position of the image. Let's add one more column in the table representing the position of the image formed at different locations of the object. Yes, this is also a property of an image formed by a concave mirror. This will also vary with the object's distance from the mirror. We can find out this position or location of the image very easily using ray diagrams. We already know how to draw ray diagrams for plane mirror images. Do you remember? There I told you that we need only two rays emerging from a point to determine the position of its image. And if we have an arrow, we take at least 2 points on it and find the image positions first. And finally, join those points on the image to get the required image of the arrow. We will do something similar to draw ray diagrams for images formed by concave mirrors also. Here is our concave mirror and the arrow representing our object. Let's talk about infinity case first. Suppose the arrow, which is our object, is at infinity. Let's take any 2 points on this arrow then. All the rays from the infinitely far away object will be striking the mirror parallel to each other. And hence the image of the 2 points will be formed at the focus. In fact, the image of all the points on the object will be formed at the focus. Yes, the image is a point-sized image. What does that mean? It means the whole image is formed at a single point. Obviously, if we were to view this image, we would not be able to see such a small image properly. It will appear highly diminished to us. Now in this case, all the parallel rays are also parallel to the principal axis. However, this may not always be the case. For instance, here the rays of light coming from an infinitely far away object and are parallel to each other, but they are not parallel to the principal axis. Here as well, all the rays after reflection will be focused at one point. So when the object is infinitely far away from the concave mirror, the image will be formed at the focus. So this is a ray diagram representing the image of an object which is at infinity. What if I kept the object somewhere else? Okay, so suppose that object is some finite distance away from C. First, we will take 2 random points on the arrow, say these 2. Now we try to find the location of these points. We will start with the upper extreme one. Just like we did for the plane mirror, we can take any 2 rays emerging from this point incident on the mirror. But we will take these 2 rays only, one parallel to the principal axis and the other passing through the principal focus. But then why did I choose these 2 rays only? Because we already know that rays which are parallel to the principal axis will converge at the principal focus. Yes, we had also seen in our past videos that the rays which are passing through the principal focus will travel parallel to the principal axis after reflection from the concave mirror. So we know now that after reflection, this ray will pass through the principal focus and this ray will travel parallel to the principal axis. And the point at which they meet is the location of the required image. In our case, it's the location of image of this point of the object. On the same lines, we will find the location of the image of the other point of the arrow. Finally, we will join these points and get the required image of the arrow. Now look carefully at this image formed. Tell me if this image is satisfying the properties mentioned in the particular row of the table. Well, if you look at the size of the image, it's certainly lesser than the object arrow. The image arrow is smaller in size than the object arrow. We say that the image is diminished. Also, the nature of the image couldn't be any clearer. It is a real image as light rays from a point converge after reflection. It's formed on the same side of the mirror as the object. It's also inverted or upside down, as you can clearly see. So where is the image positioned? Yes, it's somewhere between F and C. We note that down in our table. So this is a ray diagram for the image when the object is placed beyond C. We will continue to learn more in our next video.